It's March 14th, or Pi Day, and to celebrate, your calculus teacher has brought in a nice bundt cake for the students to eat. But then she says that, to eat the bundt cake, you have to find the volume of the bundt cake. At first, you're stumped. There's no volume formula for a bundt cake like there is for a cylinder, prism, or sphere, but then you realize you can use calculus to find the bundt cake's volume. You cut the bundt cake and graph the curve of the cross-section of the bundt cake. Because the base of the bundt cake is 5 inches and the height is 6.25 inches, this graph is a parabola with the equation of y equals 5x minus x squared. If you rotate this graph around the y-axis, you see the same shape as the bundt cake. But even with this knowledge, you struggle to figure out how rotating a parabola will get you the volume of the bundt cake. So instead, you decide to create rectangles that approximate the area underneath the parabola and then rotate these rectangles to create cylindrical shells to approximate the bundt cake's volume. In order to find this approximated volume created by the shells, you start by finding the volume of an individual shell. In reality, each shell's volume is the volume of a large cylinder minus the volume of a smaller cylinder. You write this as pi r1 squared h minus pi r2 squared h, where r1 and r2 represent the radii of each cylinder. Using algebra, you rewrite this expression as 2 pi h times r1 plus r2 over 2 times r1 minus r2, and now each part of this equation means something. The height is the function f of x, the r1 plus r2 over 2 is the average radius, or x, and the r1 minus r2 term is the difference in x, or dx, which gives the general function of 2 pi f of x, x dx, for the volume of a single shell. Now, adding up the total volume of multiple shells is still not the exact volume of the cake, but if you make the shells thinner, then your approximation will be better. And that's when you realize that if you make the shells infinitely thin, then the shell's approximation of the bundt cake will be exact. So you express the volume of the bundt cake as the sum of the volumes of the shells from x equals 0 to x equals 5, with a limit to make dx as small as possible. And then you make another realization. The integral is a calculus operation used to evaluate the limit of a summation of infinitely thin parts, so using the integral would allow you to find the volume of the bundt cake. You arrive to your final equation of the integral from 0 to 5 of 2 pi times 5x minus x squared x dx. You plug the integral into your calculator and get an answer of 327.25 inches cubed, and your answer is correct. You leave class with some delicious bundt cake. But not only that, the formula you've just discovered is known as the shell method and is used to find the volume of the solids of revolution. The shell method has many uses in both engineering and physics and shows that math is not only amazing, but has real-world application.